Chapter 11 Review. Question number 1. You are asked to find the derivatives of the given functions. A. F of x equals 3 minus 6x squared. So I'm going to use the derivative rules, and in particular, the power rules. I'm going to rewrite this function so it might be easier for me to read it. As I take the derivative, I'll bring down the power to multiply with the coefficient and subtract 1 degree to the power. And the constant, when you take the derivative, it's always going to be 0. Notice I use the symbol prime here. I'm using the symbol prime to represent I'm taking the derivative. So your final answer is going to be negative 12x. Question 1b, f of x equals x cubed plus 6x minus 144 minus 5 over x. And I would like to apply the power rule rather than the quotient rule. So I'm rewriting the last term, 5 over x, into the form of a power format, an exponential form. X cubed plus 6x minus 144 minus 5 times x raised to the negative 1 power. As I take the derivatives, so the first term, x cubed, turns into 3x squared. 6x turns into 6. And then negative 144 is a constant, so the derivative is going to be 0. And the last term, in particular, negative 5 times negative 1, I bring down the exponent, which is negative 1, multiply with my coefficient, negative 5, and then subtract 1 degree to the power, negative 1 minus 1. So I'm writing it out so that you can see what I'm doing here. Collect like terms, simplify if you can. So the final answer is going to be 3x squared plus 6 plus 5 times x raised to the negative 2 power. And you can definitely write the positive exponent by moving the x to the second power to the denominators. 1c, f of x equals the square root of x squared minus 2. This time, again, I would like to take advantage of the power rule. So I'm rewriting into x squared minus 2 raised to the 1/2 power, the rational exponent. This time I would have to apply the chain rules. So the inner function is x squared minus 2. The inner function's derivative will be 2x. And then I take the derivative of the outer. The derivative of the outer is going to be 1/2 of x squared minus 2 raised to the negative 1/2 power. Then the whole thing taking the derivative would be multiplying your inner with the outer, which reduces down to x times x squared minus 2 raised to the negative 1/2 power. And then you can definitely rewrite into x over the square root of x squared minus 2. Question 1d. 2x cubed plus 3x minus 5 raised to the second power. Taking the derivative, I will have to apply the chain rules. So I will have to take the derivative of my inner, multiply with the derivative of my outer. So my final answer is going to be 12 times x cubed plus 6 times 2x3 raised to the third power plus 3x minus 5, 1e. So that's a rational equation. Again, I would like to rewrite into the exponential form so that I can use the power rules. So that would turn into 4 times 5 plus 2x raised to the negative 1 power. As I take the derivative, the final answer is going to be negative 8, 5 plus 2x raised to the negative 2 power. Last one, 1f. Rewriting the square root into x raised to the 1/2 power. So taking the derivative using the power rule, my final answer is going to be 1/2 of x raised to the negative 1/2 power plus 8x minus 5. Number 2, you are given a function, then you are asked to find the derivative and finding the slope at one particular point, then write out the tangent line passing through that point, making contact with the graph at just one point. So f of x equals 7 minus x squared. I would like to rewrite into the standard form equals negative x squared plus 7. As I take the derivative, I find the derivative is going to be negative 2x. followed by, as I plug it in the points 1, 6 into the equation to find the slope. So x equal 1. And the derivative I found from the previous step is negative 2x. So I plug it in, negative 2 times 1, I have negative 2. That means the slope at the point 1, 6 has a slope of negative 2. Writing out the equation using the point slope form. So y minus y1 equals m times x minus x1. Y minus 6 equals negative 2 times x minus 1. Rewrite into slope-intercept form, I have y equals negative 2x plus 8. To graph these functions on the graphing paper, you will see that the function for the original given equation 7 minus x squared is a parabola opening down, and everything is being moved up by 7 units. So starting from this location, you can do your count. Right 1 down 1, left 1 down 1, right 2 down 4, left 2 down 4, because this is an opening down, negative x squared plus 7. And then the tangent line that we just calculated from the previous step, y equals negative 2x plus 8. So you will have a y-intercept point located at 0, 8, and the slope of negative 2. So right 1 down 2. So it will pass through this parabola at just one particular point, 1, 6. And this is the tangent line for this particular graph at this point. Question number 3. F of x equals x squared minus 2x minus 3. Taking the derivative, I have f of x equals 2x minus 2. Finding the slope at negative 1, 0. So I'm going to plug it in negative 1 for x to calculate, and it turns out to be negative 4. Writing out the equation, the tangent line passing through negative 1, 0. So y minus y1 equals m times x minus x1. Writing into slope-intercept form, I have y equals negative 4x minus 4. This function, you will find the parabola, the quadratic equation x squared minus 2x minus 3 has a vertical point location at negative 1, negative 4. And from here, you can do your count. Right 1 up 1, right 2 up 4, left 1 up 1, left 2 up 4. The tangent line, so we calculated, turned out to be y equals negative 4 x minus 4. So the y-intercept point is going to be 0, negative 4 with a slope of negative 4. And it's passing through negative 1, 0 at just one point. So this is the tangent line that passes through this quadratic equation x squared minus 2x minus 3 at one point only. Question number 4. You are given the limit information or the f function values, and you are asked to graph. So for my graph, it looks like unorganized, but basically your graph doesn't have to match exactly mine. I'm just giving you some idea here. So what I do here is the first one, you are given the equation f of 4 equals negative 5. So you can directly put it in this point. It's a solid dot. F of 4 equals negative 5. So find your 4, x equal to 4, y is negative 5. Followed by as x approaches 8. So limit x approaches 8, you have a limit. So that means your left hand and right hand would have to match each other. So as you can see here, the graph I have here is, so I'm trying to make it into the left hand and the right hand equals with each other, so that I have a limit at x equal to 8. Followed by limit as x approaches from the left hand side of 1. So as x approaches from the left hand side of 1, I'm coming from the left hand side of 1, it has a value of negative 3. So I'm showing you the trend here. As x coming from the left hand side, I have a value of negative 3, and this time I'm putting in an empty circle. Followed by as x approaches from the positive of 1, I have a value of 5. So again, I am showing you the trend from the right hand side of 1. Right hand side of 1, it has a value of 5. But f of 1 itself has a value of 2. So I put on a solid or field circle on f of 1 equals to 2. Next one, as x approaches negative 6 from the left hand side. Negative sign means from the left hand side it has a value, it's approaching infinity. Your y value is going to get very, very big, infinities. So that's my trend there. Next one, negative 2 from the right hand side, it has a value of, it's going to approach 2. So again, as x gets closer and closer to negative 2, it has a value of 2. So I put an open circle there. Last but not least, you have 3 from the right hand side is going to approach 8. 3 from the right hand side is going to approach 8. 3 from the right hand side is going to approach 8. So maybe I should erase this one to make my graph look more accurate by, since I have an f of 4 equals negative 5, I'm going to put it this way so that it makes more sense. But you don't really have to connect them. You don't really have to. It's just showing you the trend. As x gets closer and closer to 3 from the right hand side, it has a value of 8. Question number 5. You're asked to find the limit. Letter A, as x approaches 4. So as I plug it into the function, it will not make my denominator equal to 0. So I can go ahead and directly plug it in. 6 minus 4 squared is 16. So I have negative 10. Letter B, same thing. As I plug it in, it will not make my function invalid. It will not make my numbers inside the radical expressions a negative number, imaginary number. So I'm okay. I can go ahead and plug it in. Negative 3 plus 12, that's 9. Square root of 9 is 3. Letter C. So this time if you are trying to plug it in x equal to 3, it will make your denominator equal to 0, which is not okay. So I will have to, since my numerator, the top is a quadratic equation, I can factor it into x minus 3 times x plus 2. Reducing the factors x minus 3 from top and bottom, I'm left with x plus 2. Now when I plug it in x equal to 3, it will not make my denominator equal to 0, so I'm okay. So the limit for letter C is going to be 5. Letter D, again, as you try to plug it in x equal to 0, it will make your denominator equal to 0. And this is the case where I mentioned about the complex conjugate concept. So you're going to multiply exact same thing for your top and bottom, but make sure you use the sign. So the sign is different from your numerator. Square root of x plus 2, then plus square root of 2. Carry out the FOIL, or you call it the distributive, you'll find your answer is going to be 1 over 2 square root of 2. Letter E, finding the limit as x approaches infinity. Since they have the same degree, top and bottom, your numerator and the denominator has the same degree of x raised to the first power, a linear equation. So as x gets bigger and bigger, eventually it will be left with just the coefficient 2 over 5. Letter F, as x approaches infinity, your numerator has a higher degree than your denominator. So as x gets bigger and bigger, numerator, your top, is going to overtake your bottom so fast that the bottom is going to be a very small number compared to your top. So as x approaches infinity, your top will approach infinity faster than your bottom. So basically, the limit does not exist. Letter G, x approaches infinity. This time, your denominator has a higher degree than your top. So as x gets bigger and bigger, your denominator is going to overtake your top. So a very, very big number at the bottom, eventually it'll reach down to 0. Letter H, as x approaches 0, so 1 divided by 0, as x gets smaller and smaller and smaller, it's going to reach infinity. 1 divided by a very small number is going to become a very, very big number. Eventually, it's going to become infinity. So the limit does not exist. Letter I, as x approaches negative 1. So this time, if you plug it in again, it'll make your denominator equal to 0, which is not okay. So you will have to factor it. The numerator can be factored into x plus 1 times x minus 4. Reducing the common factors x plus 1 from top and bottom, you are left with x minus 4. Now, if I plug it in, negative 1, I'm okay. So the limit for letter I is going to be negative 5. Number 6. Find the limit as h approaches 0, f of x plus h minus f of x over h. So this is the same concept as derivative. Basically, derivative derives from this basic concept. So this is the part that where you can always go back to. The definition of the derivative is basically finding the limit. So letter A, the limit for this particular function, 3 minus x squared. If you plug it into the function f of x plus h, it will be 3 minus x plus h squared. Carrying out your calculations, you will find the limit is going to be negative 2x. 6b, f of x equals square root of x plus 2. If you carry out the limit calculation, you'll find the answer is going to be 1 over 2 times square root of x plus 2. Question number 7. Find the following based on the graph below. So letter A through D, all the values I find is going to be 4. E through H, all the values are 3. It's the function, so I and J is asking you whether a function is continuous or not. So I would like to remind you again, if your limit equals the function value, meaning that, for example, C and D matches with each other, G and H matches with each other, only and only if these conditions meet the requirement, then you can say the function is continuous. So once again, only the limit of the function equals the function value itself, can you say that the function is continuous at that particular x value. So I'm writing out for letter I write it limit as x approaches negative 7, f of x equals f of negative 7. For J, I wrote it limit as x approaches 5, f of x equals f of 5. Only when your limit value agrees with the function value, then you can say the function is continuous at that particular x. Question number 7. You're asked to sketch the graph that meets the given requirement. So your answer doesn't have to match mine. I'm just giving you some idea here. You can follow along and take a look at what you have in mind and make up your own graph. So I chose the linear equation to be the simplest one, and you can definitely use quadratic, you can use cubic or any other function to represent your concept here. So 7a, it has a negative value at f of 4, so I just go ahead and put on a dot. That's f of 4, that's at the negative value, and a positive limit as x approaches to 4. So all I have to do is put an empty circle and the limit. So limit means that your left hand and right hand would have to agree with each other. So they agree approaching a positive value. So I have an empty circle on the positive. Letter B, it has a step gap at negative 3 and f of negative 3 equals to 4. So I put on a filled circle, a solid dot at f of negative 3 equals positive 4. And it looks like a step, so I make it into a step function. Letter C, a step discontinuity at x equal to negative 2 and has no value at f of negative 4. So I just put on an empty circle and then put a step at negative 2. Last one, it's discontinuous and has a value of 3. So again, I used a solid circle to represent the value of f of 3, and the limit approaches 3 is a negative value. So that's a suggestion. For your graph, doesn't have to match exactly like mine.